Hello students, welcome to our channel. In this video, we are going to discuss about Boyle's law. And in our channel, we are providing handwritten notes for every topic which we have explained. So if any one of you need to download handwritten notes for this topic, you just go and check out the description or else comment section where I have given link to download PDF for this topic notes. So now let's move on to the topic. Boyle's law. It is a gas law and it says that for a fixed amount of gas, that means the number of moles of gas that we take in here should be constant, should be fixed. They won't be changed. So they are at constant temperature. That means here the temperature is also kept fixed. Temperature is also kept constant. So under these two conditions, that is at constant temperature and at constant gas, pressure of gas is inversely proportional to volume of gas. So it is very simple. Okay, it is very simple. At constant gas and temperature, pressure is inversely proportional to volume. That's it. Now let's understand this statement by taking one example. So first of all, I'm taking a container over here. Okay, so here we have a piston. This piston can move up and it can move down as well. Okay, so I have taken one container over here and I fixed a piston over here. Okay, so this piston can move up and it can move down as well. So now I'm keeping gas over here. Okay, so let's say these are the gas molecules and this container is closed on all the sides. Okay, so there is no possibility of leakage of gas. And if there is no possibility of gas leakage, can I say the gas molecules are constant? Can I say like that? These gas molecules are constant inside the container. And here N represents number of moles of gas. Now I am keeping the temperature of gas fixed, that is constant. That means I don't want the temperature of gas to be changed. I want the temperature of gas to be fixed. It should be fixed. It should be constant. So the Boyle's law is only applicable when the number of moles of gas constant and the temperature of the gas kept fixed. That is, the temperature of the gas should be constant. Then only the Boyle's law is applicable. So as the Boyle's law is concerned, as per Boyle's law, at the constant temperature, pressure of gas is inversely proportional to volume of gas. But this is valid only when the number of moles of gas and the temperature of gas kept fixed or kept constant. Okay. So pressure of gas is inversely proportional to volume of gas. What does it mean? When I'm increasing the pressure of gas, then volume of gas decreases. When I'm decreasing the pressure of gas, then volume of gas increases. For example, if I'm increasing the pressure of gas inside the container by moving this piston down, then what will happen to the volume? Volume will decreases like this. So it is very simple. On increasing the pressure, volume of gas will be decreases. And on decreasing the pressure of gas, volume of gas will be increases. So here pressure is inversely proportional to volume at constant gas and temperature. Here N means number of moles of gas. Now I'll remove the proportionality sign and I'll have to put the equality and I'll keep constant K. That is P equals to K by V. This is also valid at constant gas and constant temperature. So this is the first basic equation in Boyle's law and here K is Boyle's constant. Now I am just cross multiplied the above equation to get a new equation, that is PV equals to K. Up to here there are two equations in Boyle's law. Now I would say the initial pressure of gas molecules inside the container as 5 atmosphere. That is P1 equals to 5 atmosphere. And the initial volume as 10 liters. So these initial states of pressure and volume that we have taken under the same conditions, like at constant number of moles of gas and at constant temperature. So the initial state of pressure, that is P1 equals to 5 atmosphere, and the initial state of volume, that is V1 equals to 10 liters. So here we can see the more volume and less pressure. That means volume is increased and pressure is decreased. So what does it mean? Pressure is inversely proportional to volume, right? So if I multiply these two, can I get the volume and pressure as P1 V1 equals to 50, right? So now P1 V1 equals to 50. Now at the same conditions like at constant number of moles of gas and the constant temperature, if the pressure is increased to 10 atmosphere, then what will happen to the volume? Volume will decrease to 5 liters. Okay. So if the pressure is increases, then volume will decreases. And here these P2 V2 can be called as final states of pressure and volume. So now if I'll multiply these two, can I get again this P2 V2 equals to 50? Yes, again we will get P2 V2 equals to 50. It is same as P1 V1. So the products of volume and pressure of gases are always constant. So that is PV equals to K. And we know that here K is nothing but Boyle's constant. So here the product 50 is constant for both P1 V1 and P2 V2. So I'll write P1 V1 equals to K and P2 V2 equals to K. 50 is constant for both. So now I'll write P1 V1 equals to P2 V2 as a final equation. And remember that if I am changing the pressure from P1 to P2, then volume will automatically changes from V1 to V2. And also remember that here P1 and V1 are the initial states of pressure and volume, and P2 and V2 are the final states of pressure and volume. So this is all about Boyle's law. In our next video, I am going to discuss about some important graphs related to this Boyle's law. If you want to watch that video and to learn more important concepts related to chemistry, do subscribe our channel, and thank you for watching.